According to the 2014 National Electrical Code, specifically Section 350.3, the use of flexible metal conduit, or FMC, in non-approved assemblies, such as when wires are pulled through it, has length restrictions. The question at hand pertains to whether a length exceeding 6 feet is permissible if a separate insulated grounding conductor is installed within the conduit and bonded box to box. The short answer is no. Let's delve into the details to understand the reasoning behind this limitation and the relevant code requirements. Flexible metal conduit, while offering flexibility and ease of installation in certain applications, is not without its constraints. The NEC places restrictions on its use to ensure electrical safety and prevent potential hazards. One key aspect to consider is the role of the conduit itself as an equipment grounding conductor. In many electrical systems, the metal conduit serves as the primary path for fault current to return to the source, thereby facilitating the operation of overcurrent protective devices such as circuit breakers or fuses. However, flexible metal conduit, due to its construction, does not provide as reliable a grounding path as rigid metal conduit or electrical metallic tubing. This is because the overlapping layers of metal in FMC can introduce impedance, which hinders the flow of fault current. When FMC is used as an equipment grounding conductor, its length is limited to 6 feet to minimize the impedance and ensure effective grounding. The introduction of a separate insulated grounding conductor within the conduit does not circumvent this length restriction. Even with a dedicated grounding wire, the conduit itself is still subject to the limitations imposed by the NEC. The purpose of the grounding conductor is to provide an alternative, lower impedance path for fault current, but it does not negate the inherent limitations of the FMC. The code specifies that if the flexible metal conduit is longer than 6 feet, it cannot serve as the sole equipment grounding conductor. In such cases, a separate equipment grounding conductor must be installed, either inside or outside the conduit. However, even with this additional grounding conductor, the length of the FMC remains restricted. This is because the code aims to address not only grounding issues but also potential mechanical and physical concerns associated with longer runs of flexible conduit. Longer runs of FMC are more susceptible to damage, kinking, and separation, which can compromise the integrity of the electrical system. By limiting the length of FMC in non-approved assemblies, the NEC seeks to minimize these risks. To further clarify, let's consider the specific scenario mentioned. The conductors are number 12 stranded THHN, which is a common type of wire used in electrical installations. THHN stands for thermoplastic high heat resistant nylon coated. It is rated for use in dry and damp locations and has a maximum operating temperature of 90 degrees Celsius or 194 degrees Fahrenheit. The fact that the conductors are number 12 stranded THHN is relevant in determining the appropriate conduit fill, which is the percentage of the conduit's cross-sectional area that can be occupied by conductors. However, it does not affect the length restriction on the FMC. Regardless of the type or size of the conductors, the 6-foot limitation still applies. Now let's address the concept of an approved assembly. An approved assembly typically refers to a pre-manufactured system that has been tested and listed by a recognized testing laboratory such as Underwriters Laboratories, or all. These assemblies are designed to meet specific performance standards and are often used in applications where flexibility and ease of installation are paramount. In an approved assembly, the manufacturer has taken steps to ensure that the grounding path is reliable and that the conduit meets the necessary requirements for its intended use. As a result, the length restrictions on FMC may be relaxed or eliminated altogether. However, in a non-approved assembly, where the conduit is simply purchased and installed with wires pulled through it, the standard length limitations apply. To summarize, the NEC Section 350.3 clearly states that in a non-approved assembly, the length of flexible metal conduit is limited to 6 feet, even if a separate insulated grounding conductor is run within the conduit and bonded box to box. This restriction is in place to ensure electrical safety, minimize impedance in the grounding path, and prevent potential mechanical and physical issues associated with longer runs of flexible conduit. It is crucial to adhere to these code requirements to ensure a safe and compliant electrical installation. Now, let's consider some additional factors that may influence the selection and installation of flexible metal conduit. Firstly, the environment in which the conduit is installed can play a significant role. In corrosive environments, such as those found in industrial facilities or near saltwater, it is essential to use corrosion-resistant conduit materials. Flexible metal conduit is available in various finishes and coatings to provide protection against corrosion. Secondly, the type of fittings used to connect the conduit to boxes and other enclosures is critical. The fittings must be listed for use with flexible metal conduit and must provide a secure and reliable connection. Improperly installed fittings can compromise the grounding path and create a potential safety hazard. Thirdly, the bending radius of the conduit must be considered. Flexible metal conduit has a minimum bending radius, which is the smallest radius to which it can be bent without kinking or damaging the conduit. Exceeding the minimum bending radius can reduce the conduit's capacity and increase the risk of conductor damage. Fourthly, the support requirements for flexible metal conduit must be followed. The NEC specifies the maximum spacing between supports for different sizes and types of conduit. Proper support is essential to prevent sagging and damage to the conduit. Fifthly, it is important to ensure that the conduit is properly grounded. The grounding conductor must be sized according to the requirements of the NEC and must be securely connected to the grounding electrode system. In addition to the length restrictions and grounding requirements, there are other factors to consider when using flexible metal conduit. One important consideration is the conduit fill, which refers to the percentage of the conduit's cross-sectional area that is occupied by conductors. The NEC specifies the maximum allowable conduit fill for different types of conduit and conductor combinations. Exceeding the maximum conduit fill can make it difficult to pull conductors through the conduit and can also lead to overheating of the conductors. Another consideration is the ampacity of the conductors. The ampacity is the maximum current that a conductor can carry continuously without exceeding its temperature rating. The NEC provides tables that list the ampacity of different types and sizes of conductors. When installing conductors in flexible metal conduit, it is important to ensure that the ampacity of the conductors is not exceeded. Overloading conductors can lead to overheating and potentially cause a fire. Furthermore, the NEC requires that all electrical work be performed by qualified individuals who are familiar with the code requirements and have the necessary skills and experience to perform the work safely. Attempting to perform electrical work without the proper training and qualifications can be dangerous and can result in serious injury or even death. In summary, the use of flexible metal conduit is subject to specific requirements and limitations outlined in the National Electrical Code. It is essential to understand these requirements and follow them carefully to ensure a safe and compliant electrical installation. The length restrictions, grounding requirements, conduit fill limitations, and ampacity considerations are all critical factors to consider when working with flexible metal conduit. By adhering to these requirements and working with qualified individuals, you can help to prevent electrical hazards and ensure the safety of yourself and others. In addition to the above points, it is crucial to remember that the NEC is a minimum standard. Local codes and regulations may impose additional requirements that must be followed. It is always best to consult with a local electrical inspector or a qualified electrical contractor to ensure that your installation complies with all applicable codes and regulations. Furthermore, the NEC is updated periodically to reflect changes in technology and best practices. It is important to stay up to date with the latest edition of the NEC to ensure that your electrical work is in compliance with the most current standards. Continuing education courses and professional development opportunities are available to help electricians and other electrical professionals stay informed about the latest code changes and industry trends. In conclusion, while flexible metal conduit offers versatility and convenience, its use is governed by specific rules and regulations outlined in the National Electrical Code. Understanding these rules, particularly the length restrictions and non-approved assemblies, is paramount for ensuring electrical safety and compliance. Always prioritize safety, consult with qualified professionals when needed, and stay informed about the latest code updates to maintain a safe and reliable electrical system.